Okay, in this video, we're going to solve this problem right here, and so let's begin. Now, this is a pretty long trig substitution problem, so I have it all typed out. So x squared minus 6x, I'm first going to do completing the square. So I take this piece, I divide it by 2, I square it. 6 divided by 2 is 3, 3 squared is 9. So I put a plus 9 here, then put a minus 9 here, so it balances out. So then I get parentheses x minus 3 squared minus 9. This right here is equivalent to this piece. Now step 2 is rewrite. So instead of saying it in this form, I'm going to say it in this form. Then I'm going to use my reference for trig substitution. So for example, if you have the square root a squared minus x squared, you're going to use x is equal to a sine theta. But in our case, ours looks like in this form right here. So we have our x squared minus a squared. Very similar. So this piece right here, I'm going to say x minus 3 is equal to a secant theta. So in our case, instead of saying 9, I'm going to say 3 squared. So our a term is 3. So we have is equal to 3 secant theta. Then we take the derivative of this piece. The derivative of x is 1, so we have dx. And the derivative of secant theta would give us secant theta tan theta. And then we're going to swap. So instead of saying x minus 3, I'm going to say 3 secant theta right here. Likewise, instead of saying dx, I'm going to say 3 secant theta tan theta d theta. Now there's more steps to this problem, so let's continue. Next, I see this is a square root 9. So what I'm doing is factoring a 9. So I didn't show the step, so let me show the step right now. So I have 3 secant theta tan theta divided by the square root 9 parentheses secant squared theta minus 1, close it, d theta. So this 9, if I use a distributive property, I'm going to get this. Now the square root of 9 is 3. That's why I put a 3 on the outside. Likewise, secant squared theta minus 1 is the same as tan squared theta. And the square root of tan squared theta would give us the absolute value of tan theta. And in the next slide, I'm going to cover why we can remove the absolute value symbol. It involves restricted intervals. And so let's continue on. So earlier we saw this part of our reference. But more specifically, this occurs with restricted intervals. And so for example, x is equal to a sine theta for this, and this occurs whenever theta is between negative pi over 2 to pi over 2. And in our case with secant theta, it occurs between this interval right here. And under this condition, tan theta will always be positive. And as a refresher, this quadrant, everything is positive. This quadrant, only sine is positive. This quadrant, only tan is positive. And this quadrant, only cosine is positive. But in our case, 0 to pi over 2, everything is positive, so positive. And pi to 3 pi over 2, tan is also positive. And that's why we can remove the absolute value symbol. So let's say sine pi over 2. Sine pi over 2 is equal to 1. It fits this interval. Likewise, arc sine of 1 is equal to pi over 2. So we'll continue on. And now you notice 3 tan theta, 3 tan theta, we get to cancel it out. Cancel, cancel, cancel. Now all we have is the integral of secant theta d theta. And we know that that's going to be ln absolute value of secant theta plus tan theta plus c. So right now we have the form of theta. So we're going to go back to step 3. And in step 3 we said x minus 3 is equal to 3 secant theta. So if I divide by 3, I can say that secant theta is equal to x minus 3 divided by 3. Now we have to remember, secant theta is hypotenuse over adjacent. So I'm going to draw this right triangle. Hypotenuse, I'm making it x minus 3. Adjacent, I'm making 3. And then to get the opposite, and to get this side right here, we do the square root. We take this piece, x minus 3, we square it, and then we subtract 3 squared. And I can go ahead and show this step right here. So we have x minus 3 squared, x minus 3. X times x is x squared. X times negative 3 is negative 3x. Likewise, negative 3 times x is negative 3x. So we have negative 6x. And negative 3 times negative 3 is positive 9. So 9 minus 9 cancels out, and that's why we have this piece right here. Finally, we're almost done. So we have the natural log. Secant is hypotenuse over adjacent. Hypotenuse is x minus 3, adjacent is 3, plus tan theta. Tan is opposite over adjacent. Opposite is this piece right here, and our adjacent is 3. and then plus c. And this right here is our final answer. And that's all we need to do for this problem.